Okay, today we're going to talk about a few other topics that you'll need to be familiar with for polar. So we're just going to work through the 2009 Form B, question number 4. It says the graph of the polar curve r equals 1 minus 2 cosine theta for 0 to theta is shown above, or right here. Let S be the shaded region in the third quadrant bounded by the curve in the x-axis. Well, all we need is this value and this value, because we know, and it says write, this was in the no calculator portion, you did not have to integrate it, you just needed to write the expression. We know this. We need to fill this in, which is pretty obvious. 1 minus 2 cosine theta. All we need is from here to here. So I need to know what these points are. Well, I think it starts at 0, but I'm not 100% sure. Either this is 0 and this is pi, or this is 0 and this is pi. So we need to know which way it goes. So just to do a little quick theta r chart, just to see, I'm going to start with 0 and just see what I get. 1 minus 2 cosine of 0. Well, 1 minus 2 times 1 is negative 1. So this is 0. So I'm going to start at 0, and I need to go to this value. All I really need to figure out, it's sitting on 0. The r is 0. So I need to find out when 1 minus 2 cosine of theta equals 0. Well, that's when 1 equals 2 cosine of theta. So when does cosine of theta equal a half? Cosine is a half at pi over 3. And that's it. That gets you full credit for part 1, and that was 2 points. You got 1 point for your limits and your constant here, and you got 1 point for your integrand. So even if you couldn't get your limits, you could still get a point for knowing that it was the 1/2 and the squared. The next part of it, I did not grab the picture because I did not need it for this part. And this is what we haven't covered yet in our notes. It says write expressions for dx d theta and dy d theta in terms of theta. We should know that x is r cosine of theta and y is r sine of theta. We need to have those committed to memory. In order to do dx d theta, I need x in terms of theta. I need to get rid of my r. Can I fill it in from above? Here. And let me just draw a line here. Okay. You should see what I did. I just took my r value and plugged it in where my r was into both of those. Now I can clean these up before I take my derivative, or I can take my derivative like it is. I prefer to clean it up first. I'm going to go ahead and distribute through and make this cosine of theta minus 2 cosine squared of theta. Then I just take my derivative. My dx, d theta, it's just going to be the derivative of cosine is negative sine minus chain rule. The derivative of cosine is, again, negative sine. So once I do my chain rule, this is going to change to a plus, but I can just leave it like that for now. It'd be 2, leave the inside alone. Wait, that's wrong. I always have to write my cosine, and this may not help you, but it does me. Squared. 2, why am I doing that? 2 times 2 is 4. Okay, thank you. Leave the inside alone, times the derivative of the inside, which is negative sine. So my derivative of my x, my dx d theta, is negative sine of theta plus 4 cosine sine. And I had way more trouble with that derivative right there than I should have. Coming over to this one, I'm going to go ahead and distribute through. That would be sine of theta minus 2 cosine of theta sine of theta. Derivative here is a little more complicated because of this product rule. So it's dy d theta. Let me just do this. This makes my life so much easier. Okay, the derivative of sine is cosine minus product rule. I'm just going to leave my minus in the front. 1. So I'm going to run out of room. d2, derivative of sine is cosine, plus 2. d1, derivative of cosine is negative sine. Okay. and that's minus all that. So let me clean it up a little bit more. Scroll down just a bit, and there's part C. I'm going to get it in just a minute. dy d theta. I think technically you could leave it like this, but just to clean it up, I'm going to make it look like the answer on the rubric. Is cosine of theta minus 2 cosine squared of theta plus 2 sine squared of theta. The answer on the rubric, they factored out the cosine. I have no idea why. I mean, sure, let's do that. I mean, does it matter? I don't know. 1 minus 2 cosine of theta. This is the answer on the rubric, the AP rubric that gets you full credit. I believe they probably would have taken this or this, but this is what they have. So now let's look at part C. It said write an equation in terms of x and y for the tangent line. Tangent line is a tangent line is a tangent line. You do it the same way. Okay. This is going to be our dy dx. Okay. This is going to be our x, and this is going to be our y. Well, dy dx is going to be, this is dx d theta. This is dy d theta here. So dy dx would be dy d theta. So 2 sine squared of theta plus cosine of theta times 1 minus 2 cosine of theta over, this is dy, over dx d theta, which is negative sine of theta plus 4 cosine of theta sine of theta. So that's going to give me this. The thetas cancel, so I got dy dx. Now I just need to plug in my pi over 2 everywhere there's a theta. I'm not going to take the time to act. Well, yeah, I will. Sure. 2 times sine of pi over 2 squared plus cosine of pi over 2 times 1 minus, this is tedious and it's taking up time on my video, negative sine of pi over 2 plus 4 cosine of pi over 2 sine of pi over 2. This is just what you would do. I'm just going to tell you that you would get negative 2. If you work all that out, remember sine of pi over 2 is 1, cosine of pi over 2 is 0, so you end up getting negative 2. You get 2 on the top and negative 1 on the bottom, which gives you negative 2. To get my x and my y, I just use my x equals r cosine of theta, y equals r sine of theta, where r, actually, I don't have to go there. I can go right here to these formulas here. I plug my pi over 2 in to this one, and I get 0. I plug my pi over 2 into this one, and I get 1. Okay, because these are my formulas for my x and my y. I've already got them. So that's what I use down here. So I just plug in my 0 and my 1. You can leave it like that, or you could distribute it through and get negative 2x plus 1. And that is how you do an equation of a tangent line for a polar.